Hello friends, welcome to Greedypi. I am Arham Doshi and let's get started. In this video, we will be talking about time complexity. Time complexity is one of the most fundamental topics in data structures and algorithms. And if you don't know this, you won't be able to understand like a lot of concepts. So let's go. So in this course, we'll try to focus on learning something that is not already existing. So there is already a lot of resources available. So I will be suggesting few resources. Like if you have not gone through that, you first like see these resources and then come to this video, and then I will try to add something which is not already covered by other people. So the first thing I want to tell you is see the course of Abdul Bari sir. See these three videos, and you will get a lot of understanding about time complexity. And other than that, there is also a blog on Hacker Earth. So I have like attached both the resources in the sheet. Just go through that and then come to this video. So now coming back to us, our course. The what is time complexity? Time complexity is basically the rate of growth of time of like complexity is like in rate of growth of time. If it is time complexity, if it would be like space complexity, then it will be like rate of growth of like space. Like the space will not grow, but space will be occupied. So this is time complexity. So it will be like rate of growth of time with respect to input. Like it is not the actual complexity. It is not the number of operations, but it is the growth of those operations. So the time complexity is calculated by big O notation. Big O notation tells us that it is the worst case complexity. Like it can be less than that, but it cannot be more than that. So now let's understand what is big O of n. Okay. So big O of n is nothing but when n is input, you will just simply use one loop in which I will go from 1 to n. Just that. If there is one loop, then it is like big O of n complexity. Like if you are printing, like I. So now why it is big O of n? So if like n is equal to 1, we'll like consider input and output here. It will like loop will run for one instance. Like for I will go from 1 to 1, so it will print 1. So like just that word. If like n is equal to like 2, we will print two statements. That is, I will go from 1 to 2. So the output would be like 2, something like that. If it would be like 10, in n is 10, the output would also be 10, because I will grow from 1 to 10. So if we plot the graph of input versus output, like then we will see that it is a constantly increasing line. Like if it is 1, then it is also 1. If it is 2, then it is also 2. And if it is like 10, it is 10. So if we plot the formula, if you plot the equation of the line, it would be like something like that. Y is equal to A into like input plus B. And instead of Y, we can like write output also. But you got the point, right? And like in place of input, like you can like write X also. But the thing is, it is the if we plot the equation of uh, the this graph, it would be like something like that. Y is equal to ax plus b, where x is nothing but input and y is output. And um, We will consider the time complexity as the degree of this particular variable. Like if we see here, the degree of x is like it would be like something like that. So the degree of x is 1. So the y will be growing with respect to x raised to the power 1. So the time complexity would be like of n raised to the power 1. Okay. Yeah. So you guessed it right. If we are having one loop for of n, so what if we just write two loops? So you guessed it right. If like one loop is giving like n, that is like nothing but n raised to 1, then two loop will get 2. Now, why it is happening? Okay. So again, we'll do the same thing. We'll like try to plot values of input against the values of output, and let's see what happens. So like if n is equal to 1, the I will go from 1 to 1. Let's say if I will go from 1 to 1, and like j will also grow from 1 to 1. So total operation would be like only 1. Okay, so output will be 1. Similarly, if n is equal to 2, I will go from 1 to 2, and for each value of I, j will also go from 1 to 2. So for 1, the j will go for 2, 1 to 2, and for 2, j will also go from 1 to 2. So in this case, will it will print value of j 4 times in the output. Okay, you understand that? Like similarly, if the value of n is like 10, I will go from 1 to 10, and for each time, each new value of I, j will also go from 1 to 10. So if I is 1, we'll print j 10 times, and for I is 2, we'll print j 10 times, and for total, it will go 100 times, something like that. So if we plot the graph of input versus output, and we notice that if we increase like input by 1, the output will be increasing more than that particular thing. Okay. So like if it would have been normal graph, then the output would be something like that. This is a straight line. But in our case, the line will go up. So like for the value of 10, the output would be like 100. So that is very much bigger than 10, something like that. So if we plot the equation of this particular thing, it would be something like that. Y is equal to ax square plus b, something like that. And because of that, the complexity would be equal to n square. Like that is the power of variable x. So what if I write two loops like this? So in this case, the first loop will be run completely, and after completion of first loop, the second loop will be running. So what would be the complexity in this case? So the simple answer would be of n square. Why? Because we have two loops. So for one loop it is of n. So for two loop it would be n square. Simple. Yeah. No. So why no? So let's try to print input versus output again. And if like in this time, if n is equal to 1, the I will grow from 1 to 1. We'll print I one time. And after this completion, we'll go in the second loop. Again, we'll print I one time, and it would be like 2. Like for the value of input value 1, output would be 2. And if the value of n is 2, the I will go from 1 to 2 and print value of I 2 times. And after completion of that, I will go in the second loop, and in this case also, I will go from 1 to 2, and we'll like print again 2 times. So 2 plus 2 is 4. And like if we do it for 10, so we'll print here I 10 times, and we'll just print here I 10 times. So it will be going to like 20. So in this case, if we mark plot the graph, it would be something like that. So for I is equal to 1, we'll be plotting like 2. For I is equal to 3, we'll get output like 4. And for I is equal to 10, we'll get output like 20. So you will tell, so as compared to 10, the output is to 20. That is very much greater than 10. So how it is like often, but no. If we plot the graph of single loop, it would be something like this. And you can see that both the graphs are similar, just the slope is different. So the equation would be like this only: A is equal to ax plus b. And in case of like this, it will be something like 2 into ax plus b. And a is already a constant, so we can like replace it with another constant. Like, let's just see, the equation would be like something like this: y is equal to cx plus b. And this again gives us with the power of x as 1. So in this case, our slope is changing, and we can like, when calculating off like, and we can like ignore the constants that is in the multiplication of this. So it would become like off into n, and it would be just like ignore it, and it would be like off. So first thing we learned was it's not necessary that the time complexity is equal to the number of loops. Okay. Another thing we learned was if the loops are nested, something like that, then the time complexity of the loops will get multiplied. And if the loops are like one after another, in CM, another time complexity would be like added. Okay. So now the question to you is, what if it is something like this? One loop is running this like this, another loop would be like nested, something like that. So in that case, you would argue that we will be like multiplying time complexity for this, like that would be like O of n square, and we'll adding the time complexity of this, that is O of n square. The total time complexity would be of n plus n square, and this would be our final answer. But the thing is, while calculating time complexity, we will only take into the consideration the highest power, that is like n square. So in this case, it would be like of n plus like of n square, and this complexity is greater than this, so it will overpower this. So like if we plot the graph, in some case it would be like this, but if you plot till infinity, the curve would be very similar to n square, and the effect of n in that curve would be like very less. So we can like consider the complexity would be that would be equal to n square only. So now there is another one, good question for you. What if like I is going from 1 to like n square? What would be the time complexity of this? Simple, nah. We have only one loop. There is no nested loop. There is no concatenated loop. The complexity would on of n. But no. Why no? So the thing is, here the I is not going from 1 to n, it is going from like 1 to n square. So for each value, for each input of I, we will be like going till its square. For value of n equal to 1, we will be going to 1. For value of 2, we will be going to 2. And similarly, for value of n is equal to 10, we'll go to 100. And this graph would be like similar to of n square graph. So it is not necessary that the number of loop would be like equal to complexity. We have to see how many operations we are doing in that particular loop also. Okay. So what will be the complexity of this? So I is going from 1 till we go until I into I is less than n. What does this mean? So if we are going like for 1, we'll go up till if n is equal to 1, I will start from 1, and like it will go up till I into I would be less than 1, like for 1, like. So if i's value is 1, 1 into 1 is 1, so I will go from 1 to 1. If i's value is like for n's value is like 2, if we like go like for n's value 2, if we go from like here, if we try to go For I equal to 2, I into I would be like 4, and that would be like greater than 2. So we won't be going like that. Similarly, for 4, like we'll start from 1, and if we consider the value of I is equal to 2, then I into I would be like 4. So we can go till 2. Okay. Can we go till 3? That's the question mark. So what if we try to go till 3? The value of I into I in that case would be like 9, and that would be like greater than 4. So we won't be able to go till 3. So it will be going for 4. So can you find the pattern here? What would be the time complexity? Okay. Pause the video and like try to guess it. Okay. So 3, 2, 1, go. So the time complexity of this would be like of root n. Okay. So if we move the, if we like write the equation like this, and like just square root on the both the sides, then like I is simply going till like root n. So the graph would be something like this. Like if this is the n of n graph, the root n graph would be something like this. Okay. Again. So can you try to find the complexity of this particular case? In this case, I is going from 1 to n, but j is not starting from 1. J is starting from I, and it will be going till n. Okay. So like pause the video and try to find the complexity. Okay. So like 3, 2, 1. So so like if we try to answer it, what we'll notice it is, when the I is equal to 1, j will go from 1 to n. For I is equal to 2, j will go from 2 to n. Okay. So the number of values j is having in this case is like n. Number of values j is having in this case is like n minus 1. If like I is equal to n, j will grow from 1 to n. Okay, so the number of values j is having is like 1. So we'll just need to sum all this. It is nothing but the sum of like n natural numbers, which is like n into n minus 1 by 2, or like n square by 2 minus n by 2. If we like plot the complexity, we will like get something like this. N minus minus is not considered in the complexity, and of n minus 2, and like out of and removing constants, and then seeing which is the bigger one, and we'll clearly find that of n square is bigger one. The complexity of this is particular is n square. Okay. So like I will not take much time. I will just tell you one more example, and then we'll wrap up the video. Okay. So let us consider this case. In this, what is happening is I is going from 1 to n, and j is going from 1 to n, but j will be incrementing by I. So what does it mean? So if I is equal to 1, the value of j would be like 1, 2, 3, 4, 5 up to n. If I is having value 2, the value of j would be like 1, but then it will increment by 2. So the value of it would j would be like something like this: 1, 3, 5, 7 till n. And for I is equal to 3, the value of j would be like 1, 4, something like that, until n. So if we try to calculate how many values j is getting in each particular case, then like we can say that if I is 1, j is getting of j is getting n values. If I is 2, we can say that it is taking every second value. So the number of values it will get is like n by 2. Similarly, in this case, we will say that it is getting every third value. So the answer, the number of values we will be getting is n by 3. Okay. So, and for I is equal to n, j would be like just 1. And after that, if we try to add 1, it would be like n plus 1, that would be outside n. So for it would be like n by n. Okay. So if we try to sum all of this, it would be like this of n, and we can like in this case take n common, and it would be like 1. So have you seen this somewhere? It is nothing but integration of like 1 by n from 1 to like selected by n of like 1 to n into like integration of 1 to n, and you know this integration is equal to like log n. Okay, so the output of this is like n log n. So whenever there is a loop like this in which one is going from 1 to n and another is getting incremented by like the value of it, then its complexity would be n log n. It would be like very important result when we'll discuss like see. So for 1 second, when you run your code for 1 second, your computer would be able to do like 10 raised to 8 operation. So like if you submit your code, and let's say if you are submitting on code courses, and um, if it is like having 1 second as the limit, then at max you can go is like 10 raised to 8 operation. That would be like equal to like one loop from I to like 10 raised to 8, or like if you are using nested loop, then at max like 10 raised to 4 into 10 raised to 4, something like that. And like, but it is like very tight bound. So usually the standard range is like in 1 second. For safer side, you try to run only 10 raised to 6 operation. If you go above that, it will be. So I hope you learn something in this video. So after this, we'll go straight on to the sorting. So bye bye.